beneath your feet lies an energy source that could revolutionize our planet's future. Scientists have discovered vast underground reservoirs of naturally occurring hydrogen gas, called white hydrogen, that could provide clean energy for centuries without producing a single gram of carbon dioxide. Until recently, most experts believed natural hydrogen existed only in tiny, unusable quantities. But groundbreaking discoveries in Mali, France, and the United States have shattered this assumption. In Mali's Bouraké-Bougou village, a well drilled for water accidentally struck a hydrogen reservoir with 98% purity, the highest concentration ever found naturally. This discovery isn't isolated. Geological surveys now suggest that natural hydrogen deposits could be found across every continent. The United States Geological Survey estimates that global white hydrogen reserves could exceed all current fossil fuel reserves combined, potentially providing clean energy for thousands of years. Unlike green hydrogen, which requires massive amounts of electricity to produce through water electrolysis, white hydrogen emerges from the earth ready to use. No solar panels, no wind turbines, no complex manufacturing processes. Just pure, clean burning fuel created by natural geological processes that have been occurring for millions of years. Environmental experts are calling this the most significant energy discovery since oil, with the potential to completely transform how we power our civilization while achieving true carbon neutrality. White hydrogen forms through natural geological processes that occur deep within the Earth's crust. The most common formation mechanism involves water reacting with iron-rich minerals at high temperatures and pressures, a process called serpentinization. This reaction splits water molecules, releasing pure hydrogen gas that migrates upward through rock formations. Radioactive decay also generates natural hydrogen. When radioactive elements like uranium decay, they emit radiation that breaks down water molecules in surrounding rocks, creating hydrogen gas. This process occurs continuously in granite formations worldwide, potentially producing steady streams of clean fuel for millions of years. Recent research by the French National Center for Scientific Research reveals that these processes generate far more hydrogen than previously thought. Their studies indicate that natural hydrogen production could reach 11 million tons annually, enough to power entire nations without any carbon emissions. The hydrogen accumulates in underground reservoirs, similar to natural gas deposits, but with crucial differences. White hydrogen often exists at shallower depths than fossil fuels, making extraction potentially cheaper and less environmentally disruptive. Unlike oil or gas wells that deplete over time, hydrogen reservoirs can regenerate as geological processes continue. Geologists are now developing new exploration techniques specifically for hydrogen detection. Satellite imagery, soil gas analysis, and specialized seismic surveys can identify potential white hydrogen deposits, opening possibilities for systematic exploration across continents previously unexplored for this revolutionary energy source. The Mali discovery sparked a worldwide hunt for white hydrogen that's yielding remarkable results. In France's Lorraine region, researchers have identified hydrogen seepage covering over 46,000 square kilometers. Initial estimates suggest this area alone could contain millions of tons of recoverable hydrogen. Australia's Commonwealth Scientific and Industrial Research Organisation has mapped potential hydrogen-rich zones across the continent. Their preliminary assessments indicate that Australia could become a hydrogen superpower with enough natural reserves to supply domestic needs and export to energy-hungry nations for decades. In the United States, the Geological Survey has identified promising formations in the Midwest and Rocky Mountains. Kansas, Nebraska, and Colorado show particularly strong indicators of subsurface hydrogen accumulation. Early exploration wells in Kansas have detected hydrogen concentrations exceeding 20%, commercially viable levels that could support large-scale extraction. Spain's Basque Country has reported hydrogen emissions from natural springs, indicating active underground production. Portuguese researchers have documented similar phenomena along their Atlantic coast, suggesting that hydrogen generation might be more widespread than anyone imagined. Even more exciting, mathematical models predict that undiscovered white hydrogen reserves could dwarf all known fossil fuel deposits. Conservative estimates suggest global reserves exceeding 1 trillion tons, enough clean energy to power human civilization for over 1,000 years while producing zero carbon emissions. These discoveries are transforming energy geopolitics, potentially making any nation with suitable geology energy independent. Environmental scientists are unanimous about white hydrogen's potential to revolutionize climate action. Dr. Sarah Johnson from the International Energy Agency states that natural hydrogen could reduce global carbon emissions by up to 40% within 30 years if properly developed and deployed. Unlike fossil fuels, white hydrogen combustion produces only water vapor as a byproduct. No carbon dioxide, no sulfur compounds, no particulate matter, just pure H2O returning to the atmosphere. This makes it the cleanest possible fuel for transportation, heating, and industrial processes that currently rely on polluting alternatives. The extraction process also offers environmental advantages over conventional energy sources. White hydrogen wells require minimal surface infrastructure compared to oil refineries or coal mines. No massive processing facilities, no toxic waste streams, no landscape-scarring open-pit operations. Wells can be drilled with minimal environmental disruption and restored easily when depleted. Professor Michael Chen from Stanford's Environmental Engineering Department emphasizes that white hydrogen could eliminate the need for carbon capture and storage technologies. "We're talking about a fuel that's already clean," he explains. "No retrofitting required, no expensive carbon sequestration, just direct replacement of dirty fuels with clean ones." Marine biologist Dr. Elena Rodriguez highlights another crucial benefit. White hydrogen extraction doesn't threaten ocean ecosystems like offshore oil drilling. Most deposits exist on land, eliminating risks of marine oil spills and underwater habitat destruction that plague conventional energy extraction. Despite its promise, white hydrogen faces significant technical and economic challenges that experts are working to overcome. The primary obstacle is detection and extraction technology. Unlike oil and gas exploration, which benefits from decades of technological development, hydrogen exploration is essentially starting from scratch. Current drilling techniques aren't optimized for hydrogen extraction. The gas is lighter than air and can escape through rock formations that would contain heavier hydrocarbons. Engineers are developing specialized well casings and extraction methods to prevent hydrogen loss during production. Storage presents another challenge. Hydrogen molecules are extremely small and can leak through materials that contain other gases effectively. Dr. Robert Kim from MIT's Materials Science Department is developing new composite materials and coating technologies to create hydrogen-proof storage systems. Transportation infrastructure requires complete redesign. Existing natural gas pipelines can't safely transport hydrogen due to embrittlement issues. Hydrogen causes steel to become brittle and crack. New pipeline materials and compression technologies are needed to move hydrogen from production sites to consumers. Economic viability remains uncertain. While extraction costs could be lower than fossil fuels, the infrastructure investment required is enormous. Financial analysts estimate that transitioning to white hydrogen would require global investments exceeding $2 trillion over 20 years. Regulatory frameworks don't exist for natural hydrogen extraction. Governments must develop new permitting processes, safety standards, and environmental protections specifically for this emerging industry. Major energy companies are pivoting rapidly toward white hydrogen exploration, recognizing its potential to reshape global energy markets. Shell has announced a $5 billion investment in natural hydrogen research over the next decade, focusing on detection technologies and extraction methods. Total Energies has partnered with French research institutions to explore the Lorraine region's hydrogen potential. Their preliminary studies suggest commercial production could begin within 8 years if current exploration proves successful. The company plans to drill 20 exploratory wells across France by 2026. Startup companies are also entering the field with innovative approaches. iTerra, an Australian exploration company, has raised over $50 million to develop hydrogen-specific detection equipment. Their proprietary soil gas analysis technology can identify hydrogen seepage with 95% accuracy. Government support is accelerating industry development. The European Union has allocated €3 billion for natural hydrogen research through 2030. The United States Department of Energy has launched a $100 million initiative to map domestic hydrogen resources and develop extraction technologies. Investment banks are creating specialized funds for white hydrogen projects. Goldman Sachs estimates the natural hydrogen market could reach $500 billion annually by 2040, making it one of the fastest-growing sectors in the energy industry. However, experts caution that commercial viability depends on continued technological breakthroughs. Current extraction costs remain higher than conventional fuels, but rapid innovation could achieve cost parity within 15 years. White hydrogen represents a potential paradigm shift in how humanity approaches energy production and climate change. Unlike renewable sources that depend on weather conditions, natural hydrogen provides consistent, on-demand, clean energy that could complement solar and wind power perfectly. Integration with existing energy systems could happen gradually. Natural hydrogen could initially replace the dirtiest fossil fuels, coal for electricity generation and heavy fuel oil for shipping, while renewable sources handle variable demand. This hybrid approach could achieve deep decarbonization faster than relying on renewables alone. Transportation applications look particularly promising. Hydrogen fuel cells already power buses, trains, and experimental aircraft. White hydrogen could make these technologies economically competitive with fossil fuel alternatives while providing longer range and faster refueling than battery electric vehicles. Industrial applications could transform manufacturing. Steel production, cement manufacturing, and chemical processing currently account for nearly 30% of global carbon emissions. White hydrogen could replace coal and natural gas in these processes, eliminating billions of tons of annual emissions. Timeline predictions vary among experts, but most agree that commercial white hydrogen production could begin within 10 to 15 years. Dr. Amanda Foster from the International Renewable Energy Agency suggests that by 2050, natural hydrogen could supply 25% of global energy demand. The ultimate impact depends on exploration success and technological advancement. If current discoveries represent just the beginning, white hydrogen could usher in an era of abundant, clean energy that makes climate goals achievable. Thank you for exploring the fascinating world of white hydrogen with us. This naturally occurring clean energy source could be the game changer our planet desperately needs to combat climate change while meeting growing energy demands. If you found this deep dive into white hydrogen as exciting as we did, please give this video a thumbs up and subscribe to our channel for more cutting-edge environmental and energy content. Your support helps us continue investigating the technologies and discoveries that could shape our sustainable future. Don't forget to hit the notification bell so you never miss our latest videos on breakthrough clean energy technologies. Share this video with anyone interested in climate solutions. Spreading awareness about promising developments like white hydrogen is crucial for building support for clean energy innovation. What do you think about white hydrogen's potential? Leave your thoughts in the comments below and let us know what other emerging clean technologies you'd like us to explore next.